Hello, my amazing students. This is Mrs. A, and I am back for the last video of college algebra, which is our 6.7, and we are talking about our inequalities and solving systems of inequalities, and also a little bit of linear programming, which is a very useful tool. So the first thing we have to do is learn how to graph inequalities, and the first problem that's on the back of the PowerPoint is this one. So we're going to graph this inequality, and notice that the y is on the right, and generally when I'm graphing an inequality, I really like to have the y on the left. So I can turn this whole thing around if I want to and put the y on the left. So that's what I'm going to do. I'm going to put the y, I'm going to turn everything around in the mirror, and that's going to be y is less than 7x minus 3x. Okay, so basically I haven't changed anything. I just put the y on the left and flipped the sign around so that what was on the left is now on the right. The big part of the sign was facing the 7 minus 3x, so it said 7 minus 3x was greater than y. So when I turn it around, the 7 minus 3x is still greater than y, but y is less than that. So it's just a little bit easier to read. We're used to seeing things in slope-intercept form. This is not quite in slope-intercept form. If I wanted to put it in slope-intercept form, the 7 would have to be on the right. But I can graph it like this. I do know my slope is -3, and I know my y-intercept is 7. So 1, 2, 3, 4, 5, 6, 7 is my y-intercept right there. And then my slope is down 3 over 1, down 3 over 1. So I'm going to go 1, 2, 3 over 1, 1, 2, 3 over 1, and graph that line. Now this line is going to be dashed because there's no equal underneath. So less than, but not equal to. So I'm going to make this a dashed line. And then I'm going to shade in the right direction. And when you do have it in slope-intercept form, then it's easy to see because the y is less than, and y is the path of the function itself. And the path of the function is below the line. So we're going to shade below the line. But I wouldn't stop there. I would still use my 0, 0 point to check. So use 0, 0 as a test point. Plug in a 0 and a 0 right there. And then let's check to make sure, because from what we have just done, 0, 0 should make it true. So let's just double check. 0 is less than 7 because this part becomes 0 again. That is true. Therefore, we shaded in the correct direction, and that is the graph of that inequality. Okay, so the next one that we're doing is this one. And this one is not in slope-intercept form. It's in standard form, isn't it? So that doesn't mean we can't graph it. If it's in standard form, I will usually graph it in standard form, and I use my x and y intercepts. So I'm going to go ahead and do that with this one. Okay, I'm going to say I have a 1x minus a 1y, right? And so if I let x be 0, if I just cover that up for a minute, then I have negative y. Remember, I'm pretending that the greater than is an equal sign just for a moment so that I can graph the line and then worry about the shading. So I end up with negative y is -3. So since they're both negative, that means that y would be equal to 3. And if I let x be 0, then y would be equal to 3 if I'm pretending that that is an equal sign. So that would be my y-intercept. To find my x-intercept, then I will let y be 0. If I let y be 0 and cover that up, then I have x is -3. So -3 is x, and then I would go 1, 2, 3, 0, and 0, 1, 2, 3. All right, so since I've got my 2 points, it's again a dashed line. There's no equal, so we'll make it dashed. If I had a greater than or equal to, I would make it solid, but it's dashed. Then I have to figure out which way to shade it. Because the y is not by itself on one side, I'm going to use my test point. And I'm going to plug in 0, 0 because it's not on the line and it's the easiest thing to plug in as my test point. So 0 minus 0 is greater than a negative 3. Well, 0 is greater than a negative 3. Therefore, the test point makes it true, and we will shade in that direction. Okay, so this is the form of the first one that we did, and remember that this was the graph that we gave for 7 minus 3x is greater than y. So it was going through 0, 7, and it had a slope of negative 3, and we shaded below the line. So now we had this given to us, and so we're looking for a line that's going to cross at 0, 7, and this one does not cross at 0, 7, and this one does not cross at 0, 7. These two look like they could both cross at 0, 7. In fact, A and D look like they're actually the same line, but the shading is different. Okay, and remember we shaded ours below. So looking at A and D, D looks like the correct answer, and it is. Okay, so now we go over to the second one, which we were told to graph, and we graphed it like this. Okay, here was the graph. It went through 0, 3 and negative 3, 0, and it was shaded down. And here is the graph that they gave in the book, and it looks just like ours. So I'm just showing you the book answers so that you can see them as well. Okay? All right, the next one that we're going to work on is this one, and this is number 3 in the back of your PowerPoint. Y is less than or equal to the absolute value of x plus 1. Now remember, the first thing you need to do is forget about the less than or equal to and just graph y equals to the absolute value of x plus 1, and then worry about the shading afterwards. So we remember that just like all the functions we have ever done, the absolute value is a V shape, okay? And because it's x plus 1, we know it's been translated one step in which direction. What is going to make that go to 0? Well, it would be a negative 1. So it is being translated one step to the left. So what would have been 0, 0 at the bottom is going to be negative 1, 0, and that's going to be the bottom of my V shape. And my V shape will have a slope of 1, so it's going to go up 1 over 1, and up 1 over 1, and then back 1, up 1, back 1, up 1, and that is going to be the shape of the V. And it should be solid line, like that, okay? And then we're going to shade below underneath the line because y is less than. I'm going to still put in a few points to check. Now, I can put in 0, 0 because 0, 0 is not on the line. Here's 0, 0 and it's not on the graph. So if I plug in a 0 here and a 0 there, then this one becomes 1, and this one becomes 0 is less than 1, which is true, and therefore I shade towards 0, 0. So that's what the graph should look like. And that's what it looks like in the answers. I'll be showing you that in a little bit, but I'm going to go ahead and do the next one before I show you the answers because it takes a little bit of time to do that. So this one is number 4. And we're going to graph the system on one graph, okay? So we're going to have to graph, so what I'm going to do is I'm going to keep the system on one sheet, And then I'm going to erase one of these old ones and use that board for the graph because I want to be able to show you. So the first one that we're going to do is the 4y minus x. So 4y minus x is less than or equal to 2. So that's the first line that we're going to do. And so I'll just write the line right above here so we can keep track of the one that we are working on right now. Okay, so here's my graph right here. Okay, so we are going to look here, and since it's not in standard form, but it's not in slope-intercept form either. Okay, I'm just going to graph it using my x and y intercepts because that's a good way to do it when you have it in this form. So if I let x be 0, then I cover this one up and I get 4y equals 2. Remember, I pretend it's an equals at the start. So 4y equals 2 would mean when I divide both sides by 4 that I get y is 1/2. So 0, 1/2 should be a point. So 0 and 1/2. Okay, and then I'm going to let y be 0, cover up the y, and I get negative x is 2 or x is negative 2. So when x is negative 2, about there, okay, and those should be my x and y intercepts. So I'm going to pick one more point just to make sure. Okay, what happens if I let y be 1? Okay, I have y is 1/2. Let's let y be 1. So if y is 1, then I'm going to get what? 4 times 1 is 4. So 4 take away x equals 2. And then when I put this on the other side, I get negative x is negative 2 or x is 2. So when y is 1, x is 2. So let's go 1, 2, and then we can do a y that is 1. If that was a half, then we got, all right. So now our line here, we've got 3 points, and our line is going to be solid. So let's go ahead and graph the solid line going in that direction. So this is a line that has a very slight slope, doesn't it? Because it's crossing through -2, 0, and then it goes 2 steps and it only goes up a half. So that's a what? 1/4 slope. And it is, which way do you think we're going to shade it? Below or above? Okay, it's difficult to see, but we're going to plug in 0, 0 as our test point. 0 minus 0 is going to be 0 is less than 2. That's true. So 0, 0 should be shaded, so we're going to shade this one down. Okay, so that is the first line. And now we're going to, maybe we can change our color here a little bit. And we're going to put the second line on the board. So I'm just going to erase this and get the second line in this one written on the board. And it is y plus 3x is greater than or equal to 4. Okay, so there's the line, and it is going to be solid because it has an equal underneath. It's not in standard form, but it's not in slope-intercept form either. So if we wanted to turn it into slope-intercept form, that would be easy to do. We could just say y is negative 3x plus 4. So we'll just go ahead and do that for this one. And we've got a y-intercept of 4 and a slope of -3. So this was about a 1, 2, 3, 4. Okay, and we're going to go down 3 over 1. So down 3 over 1, down 3 over 1. Okay, so we have, it's going to be a solid line, something like that. Okay, and then something like that. It's a little curved. And then we're going to shade. So I'm going to plug in a 0, 0, 0, 0 greater than 4. Well, 0 is not greater than 4. So we're going to have to shade the other direction away from the 0, 0 point. So we're going to shade to the right away from the 0, 0. Okay, so there we go. Okay, now we have one more equation. So I'm going to erase all this that we had with this one. Okay, and we're going to do y is greater than or equal to 0. Okay, y is greater than or equal to 0. All right, so I got a red marker now. Hopefully it'll work. And I've got y is greater than or equal to 0. Remember, y lines go this way, x lines go this way. So y is greater than 0 is just going to be right across, and this one should be solid also, shouldn't it? And it should be going up. We can't test 0, 0, but we could plug in any y greater than 0 and it would work. So that one should be shaded above. So now look at that mess, but we have got 3 different colors to hopefully make it a little bit easier to see the graph. So now we're going to talk about what is the solution to this hodgepodge. Okay, so we've got black going down from this line right here. Okay, we're looking for everything that is shaded 3 times with 3 different colors. Okay, so this part is black, but it's not blue or red. This part is blue and black, but it's not red. Okay, now in here, right in this area, I'm trying to see so that you can see. All right, I've got the blue lines going this way, I've got the red line going this way, and the black line going down. And this little area right in here is in between the black line and the red line and the blue line. So the blue line has to be included too. Okay, so right here is above the red, it's below the black, and it's to the right where the blue is. And that area that looks kind of rectangular, but it does extend on and on, is the solution. The solution will be the part that is shaded 3 times because there's 3 different equations. Okay, so you shade the first color, we did the black first. Then you shaded the next one, we did the blue. Okay, and so we could see the part that they had in common. And then we have the red line come along, and it will cut it again, and we know that the solution has to be over here in this region because this one right here was the only place where we had blue and black. And then the red comes along, and the red cannot go over here because there's no blue. So that would be your solution. All right, so here are the answers. This was number 3, which was the absolute value that we did, and this is what we got. And they have given you the same thing, and there's their graph, which looks just like what we had. Okay, and then we did problem number 4, okay, and they're just asking you to graph the system, and then they're giving you 4 to choose from, okay, and I don't know about you, but I actually kind of have to do the problem before I know which ones. And remember, we did the problem, and here's our solution set, and we talked about it being this little sliver over here. So now you're looking for a graph that has the little sliver on the right, and the little sliver looks like it must be A. Okay, it looks like what we have, and the answer is A. Okay, so this one is one that I needed to show you on the board anyway. Find a system of inequalities with the given graph. So this one's not too hard because this one is going to be a combination of vertical and horizontal lines. Okay, now notice we have to look at a few things. The vertical line is solid and the horizontal line is dashed. The vertical line looks like it's at x is equal to 3, and then it's shaded to the left. So that looks like it's going to be x is less than or equal to 3. Okay, and when we go over to the next one, that's what it is. That's the answer board. And then we look at the y line, and it's down here at the bottom. Okay, and there we go. There's the y line dashed across there. And it says here it's at -4. So y is equal to -4 is the line, but it's shaded above. So y is greater than -4 will be the inequality. So you could have to do something like that on your final exam, and they may be not even that that easy. In other words, that one is one where you have already got lines pretty easy. I could have slanted lines and ask you those. How would you do that? Okay, well, I made up one like this. All right, I have a system, and this one looks like a horizontal line that is going through 3, 4. And this one is going through, I didn't label the point, and I should have labeled the point. Okay, we're going to look at this line here, and it's going through -1, 0. Okay, so in order to find the equation of the line, shouldn't I be able to find the slope of the line? Okay, and when I find the slope, then I can look at the y-intercept and find the equation of the line. And this equation, this looks like it has a slope of 1, because if I do 4 minus 0 is 4, over 3 minus -1 is 4, so that is a slope of 1, and then it's going through, y is 1, and so this would be y is x plus 1. All right, so now it's shaded above that line. So we could say y is greater than or equal to would be that line. And then we have a horizontal line that's going through 3, 4. Remember, a horizontal line is a y line. So the other equation would be y and 4, but it's not y equals 4 because it's got a shading. So it is y is less than 4. And since I have it solid, it would be less than or equal to. And those are the equations for that system that I just made up. Okay, so y is greater than or equal to x plus 1, and y is less than or equal to a 4. So that's not a -4, that's just a 4. It's just on the line. Okay, so that is one like problem number 5 in your back of your PowerPoint. Okay, on the next one, here it is. We're supposed to graph the system of inequalities. And again, we're going to find the x and y intercepts. If I look at the first one here, if I let x be 0, then y would be 1. And if you look at the answer graph over here, 0, 1 is a point on the line. If I look at let the y be 0, and then I get x is 2. If I look over here, then on the same line, x is 2 when y is 0. So just find your x and y intercepts, plot your line. If I look at the second line here, then I've got, if I let x be 0, then y is 0. And if I let y be 0, then x is 0. So this is going through 0, 0. And remember, the slope is -a over b. -1 over -1 is +1. So this has a slope of 1. So when I come over here, I'm looking at this one, the second line, the going down, it has a 0, 0, and it's going at a slope of 1. Okay, so that is the system. When you graph it, that's what happens. And go on to the next one. Okay, now on this one, we are supposed to graph the system. And the system has got 3 parts on it. It's similar to the one we've already done when we did the one that had the 3 colors. We did one similar to this. Okay, so I'm not going to work this one out. I'm going to let you see what they've done here. But let's talk about it for a minute before we look at it. So let's just look at line 1. And line 1, if I let x be 0, then y is 3. So 0, 3 should be a point. And then when I let y be 0, then x should be negative 9. So negative 9, 0. So we look over here and we try to find the line that they're talking about. There's a negative 9, 0. And it's going to go up through 0, 3 like we just said. Okay, so then we look at the second line here. And it's got, so basically we would have shaded that one below the line. The next one, y plus 2x is less than or equal to 10. We're going to let y be 0 and x is 5. Let x be 0 and y is 10. All right, so then we come over here and we look at the answers here. And we have 5, 0 right there. And it would go up here through 0, 10. So there's the line, and then we plug in to figure out which way it is shaded. We plug in a test point. We plug in 0, 0. 0, 0 is less than 10, so we're going to shade in the direction of 0, 0, which is right there. So they're shading down this way on the graph. And the last one is y is greater than or equal to 0. So that cuts it right off at the x-axis line there, which is the y is equal to 0 line. And it was greater than, so they're shading above the line. You get this cool little triangle is what the answer is. Okay, now, there's the whole thing a little bigger. So now we have a problem that is a linear programming problem, and it says find the maximum and minimum values of the function and the values of x and y for which they occur. So now we're going to have to plot this whole thing. Now we've got this one here is our equation that we're going to maximize and minimize, subject to all of these constraints. So these bottom 4 are our constraints, and the Q equation is the one that we're going to maximize and minimize subject to the constraints. So the first thing we have to do is plot these constraint lines. Then we're going to take the constraint lines and find the vertices where they intersect. And after that, we're going to plug in the vertices into the objective equation to try to find out which one gives the maximum and the minimum. All right, so I have written the equations on the right-hand side of this board, and I have my nice grid board here because this one's going to be a little bit complicated looking. So as I'm looking at this, I'm going to take this first one right here and zoom in on it a little bit. Okay, so I've got 3x plus 2y is 6. If I let x be 0 and I cover that one up, then wouldn't I get 2y equals 6 or y equals 3? So when x is 0, y is going to be 3. So that is my y-intercept. Okay, when I let y be 0, do that, cover that one up, then x is 2. So when y is 0, x is going to be 2, like so. Okay, so now I'm going to take this and go over to the line and graph a 0, 3, which is 1, 2, 3, and then a 2, 0, and I'm going to put a line straight through those points. So I got to change to my line here, and I'm going to put one line on this one and go straight down And that's going to be a slope of down 3 over 2, down 3 over 2, okay? And that's going to, I'm not even going to go any further than that, because notice what my constraints are down here. This is what we call a first quadrant problem, okay? I don't even need to go down this far because my graph is just going to be in the first quadrant. So I'm going to leave that one alone for right now. And now I'm going to come over here and change colors, and we'll do green here, and we're going to work on this one. So we're going to let the first part x be 0. If we let x be 0, whoops, I got to go get my pencil again. If I let x be 0, then y is going to be, so I cross that one out, I get y is 2. Okay, and then I let y be 0 and cross that one out, and I get x is -4. So -4, 0 are 2 points on this graph. So I'm going to come over here, and I'm going to do -4, 0. So 1, 2, 3, 4, 0. And then the other point is 0, 2. Now, since I'm graphing over here on the left, I'm going to have to extend this one over. So I'm going to go get my straight line, -4, 2, and then through 0, 2, and those were my points down there. I'll zoom in on that a little bit. So now we've got a slope of up 2 over 4. So up 2 over 4 would be right there, and up 2 over 4 would be right there. So I'm just trying to extend it a little ways so I know what's going on. Let's go just a little bit further because we don't know how far this needs to go. So up 2 over 4, and we're just going to extend it up 2 over 4, up 2 over 4, and that looks pretty good. Okay, so now we have 2 lines graph. So now we're going to shade these because we haven't shaded it, and I think there's a way that I can actually shade these things, but I forgot how to do it. So we'll just shade using, we're just going to shade using the pencil. So this first one that we started, we haven't shaded yet. If we plugged in 0, 0, 0, 0 is less than 6, so it's going to be shaded towards 0, 0. So we're going to be doing this little part in here. Oops, I should be using black for that. Okay, and then when we do the second one here, if we plugged in the 0, 0, it would also be less than 8. So this one would be, let's make this first one black here. So we're going to erase what I just did, and we're going to make it black so we stick with the colors of the line. So this one is going to be shaded under here. And then the green one is going to also be shaded towards 0, 0. So it's going to be shaded in this direction here. Okay, and then we've got down here, x is greater than or equal to 0, and y is greater than or equal to 0. So, whoops, that shouldn't have happened. How did that happen? So we're going to go over here and grab a pretty pink color, and we're going to do x is greater than 0, which means that the line x is greater than 0 would be this one. Remember, x lines go vertically. Okay, x is greater than 0 is going to be shaded in this direction here. Okay, and then the other line, y is greater than 0, is going to be, we'll make that one blue. Okay, so here's the y is greater than 0 line, and it will be shaded above the line as well. Okay, so it's going above to the positive direction, and now we've got this little graph. So remember, we're looking for the part that is shaded 4 times. Okay, so this, the pink and the blue is basically just saying, hey, we're going to be in this first quadrant. Nothing anywhere else is going to matter. We're just going to be in the first quadrant. The black line is limiting it here and here, okay? And then the green line is shaded down below. So it's got this little look where it's going to be, okay, let's see if we can get a red here and just do the part that's looking like, okay, so we're going to do this and then maybe this. Oops, I think I still have the line on. Okay, so let's look at the area here. So this way and this way and then this way and then up, right? So we're looking at this as being our constraint area, our feasible region, okay? And see if we can get close to it. We have to find the vertices of this area, okay? So this one is not going to be too hard because it's going to be something 0, okay? And so we have to find out where this one, the black one, had its x-intercept. But we already know where the black one had its x-intercept, and that was over here at 2, 0. Okay, so that point right down there is 2, 0. We don't have to work very hard to get that one. Okay, then the origin here, well, that's 0, 0. We know that's 0, 0. Okay, and then we know what, we got to find out what this point is. So that would be, this point right here would be the y-intercept of the green line. And the y-intercept of the green line was a 2. So we already know that point is 0, 2. Okay, so we know 3 of the 4 intersections. What we don't know is this one right here. We don't know that intersection point. So what we would have to do is find that intersection by solving simultaneously the green and the black lines. Okay, so these were the 2 equations that we have to solve, and we'll do that on our board. Okay, so here are my 2 equations. Notice I put equal signs there instead of less than and greater than, because I'm looking for where the actual lines are going to intersect. So what I'm going to do is I'm going to multiply this top equation. I'm going to use elimination. I'm going to multiply this top equation by -2, which will make this a -4y, which will add to my 4y, and poof, it'll disappear. So we're going to have -2 times a 3x is -6x. Then -2 times the 2y is -4y. And then a -2 times the 6 is a -12. And then on the bottom we got a -2. I'm just copying this line down. And then I can add them together and get a -8x. And then this cancels, is a -4. And then I divide both sides by a -8. And I get x is +1/2. Okay, so those 2 lines are crossing when x is 1/2, and that looks about right from where I am. But then we're going to have to plug in the x is 1/2 back into one of these lines. Okay, so if I plug x is 1/2 right here, then I'm going to get 3/2 plus 2y is 6. Now, this is what I said I had. 3/2 plus 2y is 6 because I substituted in the half, and that was multiplied by the 3. Now, wouldn't it be easier to do this instead of messing with the fractions? Can I just multiply the whole thing by 2? So I'm going to multiply this by 2 and get 3, multiply this by 2 and get 4y, multiply this by 2 and get 12, and I'm going to subtract the 3 from both sides, and I get 4y is 9, or y is 9/4. So we have x is 1/2 and y is 9/4, and that gives us the other point of that little quadrilateral that we needed. All right, so now we're back, and we now know what this little point is. This little point of intersection is 1/2 on the x, and it is 9/4 on the y. Okay, so we have 4 vertices to this quadrilateral, which is our feasible region. Okay, where all of these, kind of like a vortex, where they all intersect. Now, linear programming says that if I'm going to have a maximum and a minimum to my function, it will always occur at the vertices of the region. So now I'm going to plug in my equation, which is my objective equation. My q is 2x plus 5y. I'm going to plug in each one of these points. All right, so here was our objective equation up here. This is the one we're trying to maximize and minimize. These were the 4 points that were the vertices of the quadrilateral. So when we plug in our x and our y here, 0 and 0, our q is 0. So q is 0. That's definitely about as minimum as we're going to be able to go. We also call that the trivial solution, because very often you don't want something to go to 0. But 2, 0 would be when I plug in x is 2 and y is 0. So I'm only going to get a 4. So q would be a 4 when I plug in 2, 0. When I plug in 0, 2, then x is 0, y is 2, and I would end up with q is 10. Okay, and then lastly, if I plug in x is 1/2, I'm going to end up with a 1 on this side. 2 times 1/2 is 1, plus, and then over here, 5 times 9/4. Well, that's going to end up being 45/4. Okay, so then I'm going to add the 45/4 to the 4/4. Can't I turn this 1 into 4/4? Okay, and I end up with 49/4. Okay, and 49/4 is going to wind up being 12 1/4. Okay, so because 48 divided by 4 is 12 wholes, so this is going to be 12 1/4. And when you look at all the values of q, we had 0, 4, 10, and 12 1/4. 12 1/4 is the maximum. So your answer would be that the maximum was 12 1/4, and it occurred where x was 1/2 and y was 9/4. Your minimum occurred when q was 0 is your minimum, and it occurred when x and y were both 0. Okay, so that would be the first linear programming problem that we have done. And it takes a long time. But linear programming is very useful for a lot of business applications where you have several things that you've got to take into consideration.